This video is about refraction and total internal reflection. And the equation we will be using here comes from Snell's law. n1 sine theta 1 equals n2 sine theta 2. Imagine we have an interface between two different media here. This is medium 1 and this is medium 2. The refractive index of medium 1 is n1 and the refractive index of medium 2 is n2. The blue arrow here indicates the direction of a wave which is incident on the boundary between medium 1 and medium 2. This can be any sort of wave, but it's handy and convenient to use light waves as our model. The arrow is a ray which indicates the direction of the wave. In optics, angles are always measured from the normal. So here we have the angle theta in medium 1. We'll call that theta 1. The normal is an imaginary line that passes through the medium boundary at 90 degrees to the medium boundary. The ray can refract, and as you can see in this diagram, the ray has refracted away from the normal. That is to say, theta 2 is larger than theta 1, but it depends on the refractive indices of these media. By way of an example, let's imagine the situation where we have a ray of light incident on a boundary between glass, which has refractive index 1.5, and water, which has refractive index of about 1.3. In this situation, let us say that the angle of incidence, that is, the angle that the incident ray makes to the normal, is 20 degrees. What would the refracted angle be? That is, the angle between the normal and the refracted ray, in this diagram theta 2. We take the equation that we have at the top of this page and we rearrange it to get theta 2 as the subject. I've written that at the bottom of the page here. I've divided through by n2 and then I have taken the arc sine of both sides of the equation. Please don't forget to take that arc sine or your answer will be incorrect. The other important thing is to make sure your calculator is in the right mode. If you are using angles in degrees, you must make sure your calculator is calculating the sine of an angle in degrees. When writing out your working, it is important to be clear and methodical so that you do not forget to take this arc sine at the end. Now I've modified the question slightly to show you something that can happen. Here I've got the angle of incidence as 62 degrees. Now if you try to put this into your calculator, you'll have a problem. Your calculator may either give you math error or syntax error, or if you have a very sophisticated calculator, it may even give you a complex answer. And that is because you are trying to take the arc sine of a number that is larger than 1. And if you remember the graph of sine of an angle versus the angle, it only goes from 1 to -1 on the y-axis, so it's just not possible. Well, what does this tell you? This tells you that there is no refracted ray. All of the light intensity is reflected at this boundary back into medium 1, and none of it is transmitted through into medium 2. So that's called total internal reflection. The angle of reflection is equal to the angle of incidence. And you can calculate the maximum angle of incidence that will give you refraction. And so I should say the minimum angle of incidence that will give you total internal reflection. And we call that the critical angle. We do that by supposing that the refracted angle, the angle of refraction, is 90 degrees. So theta 2 would be 90 degrees. We would then substitute our numbers to find what theta 1, the critical angle, would be. And any theta 1 larger than this critical angle would cause total internal reflection. Any theta 1 less than this would have refraction. The sine of 90 degrees is just 1. And in this case, the critical angle is 60 degrees. Now we've mentioned refractive index quite a lot. What is refractive index? The refractive index of a medium, which I've indicated with a lowercase m as a subscript here, is equal to the ratio of the speed of light in a vacuum to the speed of light in that medium. In other words, it's a factor of how much light is slowed down within a medium compared to a vacuum. The refractive index of a medium cannot be lower than 1 because that means light would be going faster than in a vacuum. And as a rough idea, the refractive index of glass is about 1.5, but it does depend on the glass composition.